All right, so yesterday we learned the three trig ratios, sine, cosine, and tangent. And today I'm going to show you how to use those three ratios to solve for missing parts of a triangle. Now, you definitely need your calculator today. And notice that to ensure that we get the correct answers, we have to make sure your calculator is in the degree mode. All right, so if you have a graphing calculator, and we go into mode, which is right next to your second button. All right, you'll notice sometimes you are what's called left justified, and the word radian might be highlighted. And if it is, then you need to arrow down and make sure that you get the word degree highlighted. If you don't have a graphing calculator, but a scientific one, up in the corner, you should see a little DEG. That signifies that you are in the degree mode. Okay, so once you have that highlighted, you can quit out of there and we'll be ready to use it. All right, so to work these problems, all right, first of all, let's just look at number 3 so that you understand how to know to even do trigonometry. Because we've already reviewed the Pythagorean theorem. So if I was trying to find this side, the only way that I can use the Pythagorean theorem is if I know the other two sides. All right, so when you look at the picture and you don't have all three sides labeled, then you have to have a different method than the Pythagorean theorem. With trigonometry, though, we have to be given an angle measure. So we need at least one other side and one of the acute angle measures, I should say. We're never going to use the right angle in our trig equation. All right, so I know I have to do trig. So I'm going to label my triangle with respect to the given acute angle as either the hypotenuse, opposite, or adjacent. All right, so here's my given acute angle, the 24 degrees. So with respect to that, all right, across from the right angle, the 30 is the hypotenuse. All right, across or opposite the 24 degrees, this would be my opposite side. And so the letter U is acting as the adjacent side to that 24 degrees. So now we need to identify which trig function we should use based on what was given and what the missing side is. So notice there is nothing over here on the opposite side. So I'm not going to use that. So what's left is adjacent and hypotenuse. Well, which trig function uses adjacent and hypotenuse? If we use the SOHCAHTOA, you'll notice the A and the H go with the C, which stands for cosine. So we're going to write an equation. It is always the trig function of the angle measure, so cosine of 24 degrees equals, and then we write our ratio, always adjacent over hypotenuse. So it's going to be U over 30. Again, I must see the labeling, and I need to see this equation. So I know you're using the right trig function and you've got the correct ratio. All right, now, before we go to our calculator, just imagine that this side is over a 1 and we've got a proportion. I'm going to cross multiply. So I've got U times 1, which will be U, equals, and then what I'm going to do is the 30 times the cosine of 24 degrees. All right. I'm trying to solve for you, so I'm just going to punch that into the calculator. So now I go and all I type in is 30 times, you hit the cosine button. I'll show you right here. So 30 times, and then I hit cosine 24 equals. So U is going to equal 27, and we'll just go to the tenths place, 0.4. Now all I can tell you, all right, is to check to make sure your answer makes sense. The U is one of the legs. We already know the hypotenuse is 30, so we should get a value less than 30, and we did. So hopefully we did everything right, and that because that answer certainly does make sense. All right, notice 3 steps. So equation, what you get when you cross multiply, and then your answer. That's what I need to see for all these problems. Let's look at number 4. All right, so again, can't use Pythagorean theorem. I am given an angle measure. So with respect to that angle measure, what I have is I've got, well, across from the right angle, so the R is the hypotenuse. And then across from the 38 is the 21, that is opposite. Now notice this time, I'm not even labeling the adjacent side because I'm not going to use it. I only labeled the parts that are actually given. So I can see O and H, opposite and hypotenuse, that would be the sine. So I'm going to do the sine of the angle measure equals, and it's always opposite over hypotenuse. So this time notice the variable R fell in the denominator, and that's okay. Sometimes it's in the numerator, sometimes it's in the denominator. So that's step one. So step two, I'm going to pretend this is over 1 and I'm going to cross multiply. So this time when I cross multiply, I've got 21 times 1. So 21 is going to equal, and then I've got R times the sine of 38 degrees. All right, there's nothing to punch in the calculator yet because R is not by itself. To get R by itself, I'm going to have to divide both sides by the sine of 38 degrees. Now I go to my calculator, and this is what I'm punching in. 21 divided by, and it will be the sine of 38. All right. Now notice, since I don't need to necessarily close that parenthesis because it's at the end of what I'm typing in. All right. So I can just hit enter, and we're going to get 34.1. Again, that makes sense because R is the hypotenuse, and that number is larger than the one leg we know of 21. So we hope we did everything correctly. Let's do another. All right, can't use Pythagorean theorem, but I do have an angle measure and one other side, so trigonometry is going to work just fine. So with respect to this, 27, the Z is opposite. And let's see, I don't have the hypotenuse, so that makes the 52 the adjacent. So this time I'm working with opposite and adjacent. That's my tangent. So I'm going to do the tangent of the angle measure, 27 degrees. And again, make sure you get the ratio right. It's opposite over adjacent. So this time it's going to be Z over 52. So that's my step one. Step two, pretend this is a proportion, that it's over 1. We're going to cross multiply. So I'm going to get Z equals. Now this time I'm going to just type this in a little different because I want you to see how you have to do it on the calculator. So I'm going to do tangent 27 times 52. Could have done 52 times tangent of 27, doesn't matter. But when I go to the calculator to type it in, if you do write it that way, oops, sorry for the glare. All right, notice this is where closing the parenthesis is important, because if I don't, then it's going to do the tangent of 27 times 52. But I only wanted to do the tangent of 27. Then I'm going to multiply it times 52. So just be careful when you're typing in. All right, so then the third step, Z would be 26.5. Okay. Now you don't need to number your steps, but these are your notes. So I want to make sure that you see there are at least 3 steps that need to be shown. Now this last problem, number 6, we've got 2 missing sides, not just 1. All right. It doesn't matter which one we do first. Let's go ahead and label. So with respect to the 20 degrees, all right, across from the right angle, that makes the 12 the hypotenuse. Across from the angle, the 20 makes Y the opposite. And then that makes the X the adjacent. Obviously, I can't use these 2 legs because I've got those where my 2 variables are. So let's cover up one variable at a time. Let's cover up the Y. And in order to solve for X, I'm going to need the trig function that uses adjacent and hypotenuse. That would be the cosine. So we're going to do the cosine of 20 degrees, and that would equal adjacent over hypotenuse. That's the one I need for x. Let's go ahead and write our equation for y. So to do that, I'm going to cover up x. And notice to solve for y, I'm going to use the trig function that's opposite and hypotenuse. That's the sine. So the sine of 20 degrees would equal y over 12. All right, so those are the two that we need to solve. And let's do it. So when I cross multiply the x equation, I'm going to get x equals 12 times cosine of 20. Punch that in. 12 times cosine of 20 is 11.3. Over here, cross multiply, we're going to get y equals 12 times the sine of 20. 12 times the sine of 20, 4.1. Now, again, checking to see that they make sense. The hypotenuse was 12 and both our legs are less than 12. For this one, we could actually, real quick, even though we rounded these, type that into the Pythagorean theorem and see if we got really close to 11.3 squared plus 4.1 squared equaling 12 squared. All right, it'll be a little off because we rounded these answers, but we could always do that to check. All right, so this is what you're doing today. We're finding and solving for missing sides of our right triangles using trigonometry. All right, remember, sometimes the variable will land in the numerator, but sometimes it does land in the denominator. And when that happens, like back in example 4, you're going to be dividing, not multiplying. All right, come see me if you need any help. Time to practice.